So what is the coefficient of friction? Coefficient of friction is the ratio of force with the normal reaction. Now, suppose that a body is resting over another body. A body is stable. This body is stable over another body. Now, this body will exert its own self weight in downward direction, and according to the Newton's third law, the table also exerts the equal and opposite reaction in upward direction, and that we call it as a normal reaction, that is capital N. This is its self weight, that is W. Okay. Now, if a force is applied to this block in forward direction, such as force P, then in such case, a friction will appear at the downward side, at this side. That is a surface which is in contact with the object and the table surface. So this surface will experience certain friction in the opposite direction to the motion. So remember this thing, that your friction is always in opposite direction to the motion. Friction is always in opposite direction to the motion. So therefore, your direction is in this side. Okay, your direction is in this side, and therefore your friction will be in opposite side. Your friction will be in this opposite side. In this side, your friction will be there. Okay, so therefore you have to draw the friction in opposite direction. So this will be your friction. So friction is normally represented here by capital letter F. And therefore, from this diagram, we can write it down here that coefficient of friction, that is coefficient of frictional force, is equal to your F divided by N. Coefficient of friction is F divided by N. And basically what we call a notation for this coefficient of friction is nothing but mu. Is mu. So coefficient of friction mu is equal to F divided by N, where F is the limiting friction and N is the normal reaction between the contact surfaces. Okay. So therefore, we'll write it again. Mu is equal to F divided by N. Mu is equal to F divided by N. Okay. Now, there are certain laws of friction. So, such like this. This is the law of friction. This one is also the law of friction. That is, friction is always in opposite direction. If your force is applied in this direction, then friction will be in opposite direction always. So this is also the one of the law of friction. Okay. Now the next law is, till the limiting value is reached, the magnitude of the friction is exactly equal to the force which tends to move the body. Okay, till the limiting value is reached, the magnitude of friction is exactly equal to the force which tends to move the body. Okay, means at the maximum value, whatever the force you are going to apply, that value of force will be equal to the frictional value. If the force overcomes that frictional value, then the body will move. Okay, what is the meaning of this? That you are applying force in this direction. If this frictional value is less than the force applied, then only this body will move in rightward direction. In the rightward direction. Okay, so therefore the limiting values are there. Okay, if the force overcomes the limiting value, then the body will move in right direction, means in the direction of force. Okay, so therefore in that case your P will be greater than F. In that case, if your body moves, this means that your P will be greater than F. Okay, and if your body does not move, means that P will be less than F. So these two conditions will be there. If body does not move, this means that P will be less than F. If body moves in right direction, this means that P will be greater than value F. Okay. Now after that, the magnitude of the limiting friction bears a constant ratio to the normal reaction between the two surfaces of contact, and that ratio is called as coefficient of friction that we have just seen. Here. This is the third law of friction. Now the fourth law is the force of friction depends upon the roughness or smoothness of the surface. If your surface in contact is rough, then your friction will be more. If your surface of contact, this surface is smooth, then your friction will be less. So remember this thing. Okay, and the next one is the force of friction is independent of the area of contact between two surfaces. Means this one is the area of contact, and the force of friction is independent of this thing, the area of contact. Okay, so the force of friction may vary, but it is independent of the area of contact. Okay. See here, the force of friction depends upon the roughness. If your surface is rough, then the friction will be more, means F will be more. If your surface is smooth, then the friction will be less. Okay, and next one is your value of force of friction is independent of the area of contact. Means if area of contact is 1 meter square, then also value of F will be same. If area of contact is 2 meter square, then also the value of force of friction will remain same. Why? Because your P is independent of the area of contact and F is dependent on the P. So therefore, both are dependent on each other. Your F is dependent on P. F is not dependent on the area of contact. Right? F is not dependent on the area of contact. F is dependent on the P. F also dependent on the angle. Here the angle is 90 degrees. Here the angle is 90 degrees. So therefore, no need to take the sine cos tan here. Your angle is 90 degrees. Okay. Now after that, your value of coefficient of friction. In numerical, they are going to ask you, what is the coefficient of friction? So you are going to use this formula. Coefficient of friction is equal to F divided by N. What is the value of N? Value of N will be the value of W here. Your value of N will be value of W. And what will be value of F? Value of F is given here. That is the force of friction. Okay. And from this, you are going to calculate the value of mu. That is coefficient of friction. Okay. Now after that, when the body will start move, means if P is greater than F, then your body will start move. The dynamic friction comes into the action. Means if the moving condition is there, then the dynamic friction will be there. If the body is trying to move in direction with force P, then dynamic friction will come there and the sliding friction will occur there because the body is sliding. The body is not rolling. This is a rectangular body. This body cannot roll. This body can only slide. So therefore, sliding friction will occur there. The magnitude of the which friction less than the limiting friction and it bears a constant ratio with normal force. This ratio is called as the coefficient of dynamic friction. Now, if the friction is dynamic, then this coefficient will be coefficient of dynamic friction. But currently, we are only looking for the static friction. We are not going into the dynamic friction. Okay, so therefore, remember this formula only. That is mu is equal to F by N. Now, after that, there is an angle of friction. There is one more term, that is the angle of friction. This term is also very important. That is the angle of friction. Now, what is the angle of friction? Angle of friction is also represented by your tan of theta, and tan of theta is also equal to F by N. Okay, now here you have to pay the attention because this thing is important. Remember here that what is the angle of friction? First of all, understand this. If your object has been applied with a force P, then in that condition, this F can be drawn here. F can also be drawn here. Okay, by the property of parallel forces, you can take this force F parallel here. Okay, now your force F, this one is your force F, and this one is the normal reaction, that is N. N is acting in upward direction. Okay, now F and N is there, and if two forces are there, then their resultant must be there. Then their resultant must be there. So therefore, let us assume that R is the resultant. Let us assume that R is the resultant, and by the triangle law that we have learned in the unit number 1. What is the triangle law? Triangle law means if this is in one direction, if this is in second direction, then the resultant of these two forces will also be the third side of the triangle taken in opposite direction. Okay, their direction is this. Anti-clockwise direction is there for these two forces. You can see here the anti-clockwise direction. But the direction of the resultant is opposite to the anti-clockwise. Opposite to the anti-clockwise, and that must be the resultant. That must be the resultant. This one will be the capital R. That is the resultant of your force system. That is two forces, N and F. R will be the resultant. And the angle made by this resultant with the normal reaction, this angle will be your angle theta. This angle will be angle theta. So therefore, this angle is your angle of friction. This angle is your angle of friction. And tan of theta is equal to F by N. You know what is the tan? Tan is the opposite divided by adjacent. So therefore, for the angle theta, opposite is your capital F and adjacent is capital N. So therefore, F divided by N will be your tan of theta, and tan of theta is represented as an angle of friction, as an angle of friction. Now from these two equations, what you can say, from these two equations, both are having F by N on the right side, both are having the F by N on the right side. So therefore we can equate these two things, and therefore tan of theta is equal to mu. Tan of theta is equal to mu. So therefore we can say this thing, that tan inverse of mu is equal to theta. So therefore we can say this thing, that tan inverse of mu is equal to theta, which is nothing but the angle of friction, So tan inverse of mu is nothing but your angle of friction, that is theta. So therefore, hence we have proved this thing, and this thing will be useful in solving the numericals. Okay, in solving the numericals. So therefore, in numerical, they will ask you what is the value of mu, that is coefficient of friction. In numerical, they will ask you what is the value of theta, that is the angle of friction. So firstly, if you find out the mu, this value, then you put this value here, tan inverse of mu, and you will get the angle of friction. Okay, so for finding out the value of mu, you should have the value of F and N. So they will provide you the value of F and N. So therefore, this F and N value are important for you. This value will be given in numerical, and from this value, they will ask you to find the value of mu and value of angle of friction, that is theta. And both values you are able to find out. So this is the theory behind the numerical based on this thing. So you try to remember this thing, because this thing is the basic of the friction. If you know this thing, then you are able to solve the numericals of the friction. This is the most basic lecture of the friction, and I request you that you watch this lecture again and again. Okay, you watch